Went by really fast, didn't it? Looks so long on paper. To get started here, we're gonna set up our OneNote notebooks for this semester. So if you guys can take out your tablet and open up Microsoft Teams, we'll start by doing that.
At least you have her this semester. You always have someone.
So when your Microsoft Teams opens up, you should be at a screen that looks like this with the tiles. Hi, John.
Sorry.
No problem. You should see a tile for 5th hour IBSL. Does anybody missing that?
Oh yeah. I agree.
Yeah, if there's like a Teams tab on the side that you might need to click.
Like COVID.
So you should be, yeah. So is anybody missing a 5th hour tile? I went and added you guys all in the other day, so everybody hopefully should be here. Okay, click the tile. So then click the 5th hour tile. You should go to a screen that looks like this. Shh. Click on the notebook option here on the side. Good morning. And it'll populate this notebook. If you hit the ... you should have some options. One of them should be open in desktop. And once you've done that, you're all set. Yeah, I think if you hit that editing tab, it arrows over. Over there on try the viewing. Anybody still working on getting their OneNote opened? Okay. Fantastic.
So you get like lined up like
Who's your other setter?
you know that guy he's got the sharpest and symmetrical edge like out of his skin right here.
She's good, but she's really lazy. So like, she just doesn't get her
I'm wondering about the
feet
summer.
or she like
I would do it in the summer. Yeah, I don't know how you did
And
now.
she, like,
My head's so cold.
she'll every storm, like, she'll send me just because she's good at it. But our middles are good, so I guess it's not like.
Dude, I think you know what
No, it's Riley and
I was like, I'm sorry to break it with you. No, I wasn't like.
Alina committed to. She's actually really good. She's just like a really good one.
He's so annoying.
Oh my god, what's so bad?
Maddie, it's impressive how one can touch. Probably five. And Kim actually hit the ball. Like you jump higher than everyone. And just any high school ball. And you hit it.
running spike on my side. I'm like, oh,
It's like actually impressive.
He went to my side like 10 times.
And I just know it's
Who's the other dad?
very
Power
fair.
fighter.
She's
All right.
very light.
Hi, everyone.
It's not very good.
My plan, as it was pointed out to me, I totally forgot. So initially I had planned on starting just in chapter 2, but as somebody pointed out to me, like, Mr. Kulik, we never finished chapter 12, and oh my gosh, we didn't. So what we're going to do today is we're just going to kind of do some chapter 12 practice stuff by ourselves or as a class to kind of get reacquainted with like what the heck were we doing 3 weeks ago that I've completely forgotten about. So today just basically will be a chapter 12 review. So I'm just going to pull problems from the chapter 12 review. I'll kind of start in on doing some of these myself. Eventually, I'm going to want some help from you guys in doing these things. But that's our plan for today. We'll do, what would you rather do sequence-wise after today? Would you rather do, well, I think probably we'll do actually I shouldn't, there's no option. We'll do quiz and activity next time, and then the test for chapter 12, the class after that. Yeah, with the activity. So like today, when we're doing the review for chapter 12 stuff, like get the most you can out of it, right? Because now keep in mind, this is all things we've done. You did this all last semester. And I'll talk about quiz format and stuff here at the end, okay? I know, I'm sorry. It was better than cramming it in at the end of last semester, though, wasn't it? Okay, yeah. All right. So it says, the first question says, residents of a small town have savings which are normally distributed with a mean of 3,000 and a standard deviation of 500. What percentage of townspeople have savings greater than $3,200? So the key here, the words that are going to tell me what to do are normally distributed. So there's kind of two ways that I can do this. So if I remember the shape of a normal distribution, it's like that bell curve, right? And the center of my bell curve is going to be the mean. And then like each standard deviation looks like this, right? Oops, that should be like 3,000 or 2,500. Everybody's okay there? So what we're looking for then is, that's basically where 3,200 is. we're looking for the area under that curve past 3,200. How do I know I'm going to the right of 3,200 rather than to the left? Yeah, very good. Because we're looking for the probability that we are greater than 3,200. So to do this, now that I kind of intuitively understand what I'm doing, I'm going to use my calculator to actually do the computation. So I'm going to press second and the vars button that opens the distributions menu. And I have 3 options for normals that I would be potentially using: normal PDF, CDF, and inverse norm. Which one would I want to use in this particular setting? So I press second and the vars button that opens up the distributions menu. So since we're talking about a normal distribution, I know I'm only going to be looking at one of these first 3 options: normal CDF, PDF, and inverse norm. We want CDFs. Well, I will tell you this: when you're doing a normal distribution in this class, you are never going to do a PDF. So how's that?
Pretty good.
Sounds pretty good. So we'll do normal CDF. So what is the lower value in the picture that I've drawn here? It's 3,200, right? That's the lower of the shaded piece that I'm concerned with. Sorry, I was unclear there. So that's what I'll put in for lower. The upper, for the shaded piece that we've drawn here, what's the upper value? Nope. Positive infinity. Now I can't type positive infinity into this kind of calculator. So what I'll do is 1, and then I'll do times 10 to the 99th. Is everybody okay with that? Or actually, I guess I could do 9. That's the same number of digits, but it's a bigger number. That's the biggest number I think our calculator can hold. Do you know how to get that capital E? That was second, and then the comma button. What does mu stand for? What does mu stand for? That's the mean. So in that place, I'm going to put 3,000. And what does sigma stand for? Standard deviation. So there I'm going to put the 500. I hit paste and enter, and there's my answer. Is everybody okay? 500. It was given to me in the problem. 9e to the 99th. No.
If there's like a clear, like.
Sometimes it'll be between 2 specific values. Sometimes it'll be a lower that goes to negative 9e to the 99th. So it just kind of depends on the context of the problem. That's why drawing the picture to start with is really helpful. Yes.
I'm getting an answer.
You did normal CDF.
Yeah. 1,300 as the upper, the lower.
Okay.
And then 9,999.
Okay.
The upper 3,000.
The mean should be 3,000 and the standard deviation 500.
Yeah. I'm getting negative 0.5.
I think you must have pressed PDF and not CDF.
Yeah.
It should not, I mean, a normal CDF can't give you a negative number. Like it just, it's a probability, so it can't output a negative for you.
It says normal CDF on top.
Weird. Can you come and show me your calculator? I don't have any good reason as to why it would be giving you a negative number output.
Yeah.
That's really bizarre to me.
Sounds like set my calculator.
Oh,
Yeah, I had a feeling. Yeah.
it's that one. Yeah, that's it.
Oh. Is that the right answer?
Mm-hmm. What in the name of Betsy did it? Why did it do that? That doesn't even make any lick of sense to me.
Should I reset my whole calculator? Or?
There we go.
Why was there like an E on it? Oh. Yeah.
Don't know.
Hopefully I don't have to do that.
Yeah, I don't think you should. I think that like, but that did it then, right? Okay. All right. Next question here says part B says 2 townspeople are chosen at random. What is the probability that both of them have savings between $2,300 and $3,300? So it's an and probability, right? Townsperson 1 and townsperson 2. What is the rule for and probabilities? An and probability means multiplication. Is everybody okay there? Now, in all reality, the probability that one townsperson has savings, or any townsperson has savings between such or 2 such values is going to be the same, right? So it's really just going to be like whatever the probability one of them is squared. Is everybody okay there? So to get that one probability, I'm going to do that in my calculator. So I'm going to go vars, or second vars distributions, normal CDF. My lower here is going to be 2,300. and my upper is going to be 3,300. My mean and standard deviation will remain the same. So that's the probability of one person. I'll just take that number and square it. That should be the probability of two of them. Oh boy. So I get about 0.416. Yeah.
How do you know when to use the CDF and the
So if you're doing a normal in this class, you will never do a PDF. We will use inverse norm. That's okay. But we will never use a PDF for normals. You can use a PDF for binomial, but not for normals. Okay? Is that good?
So when do you use the CDF? Oh.
So, Alessa, CDF stands for cumulative. So if the problem is involving an inequality, like less than or greater than, those are always CDF problems. So like here we were looking for the probability we're less or greater than 2,300 but less than 3,300. That means it's a CDF problem. Is that?
That makes sense.
Okay. Short. All right. Part C says the percentage of townspeople with savings less than D dollars is 74.2% or 22%. Find the probability D. So far, so good. That's what we're given. Now, we're about to use the inverse to do this. Now, the inverse only works for the form or for less than or equal to inequalities. Okay? The inverse, whether it's a binomial inverse or a normal inverse, only works on our calculator for less than or equal to inequalities. What kind of inequality did I write here? Less than. So you know what I need to do? I need to rewrite this as a less than or equal to. Everybody's okay with that? So far, so good? Now, remember, in this normal distribution, what we're talking about is like the area under the curve, right? So like if we draw our normal distribution or whatever, looks kind of like this. You know, I have my mean and then like, you know, some standard deviations away from the mean or whatever. Let's say we have, this is D here, and we're looking at strictly less than D, right? Everybody's okay with that? So that 0.7422 is that area that I've shaded there. So far, so good? If instead of making this a dashed line, if I include the area if I do that, so now the area includes that line D. Did it change the area at all? No. Why not? Think back to geometry. What kind of geometric figure is a line? It's one-dimensional, right? It just has like length or width or whatever. It doesn't have both. What is the area of a line? 0, right? It has no area. So whether I include that endpoint, that ending line, or not, when I'm doing a normal CDF, it doesn't matter. Is everybody okay there? It will matter if you're doing a binomial. There it matters a lot. But in the case of a normal, it doesn't. They're the same. Whether it's less than or equal to, they are the same in normal distributions. Is everybody okay there? And that's what we're doing right now is normal. Yes. So this is now properly formatted. All I need to do is to do the inverse norm here. So I'll go back to my distributions and select inverse norm. The area is the 0.7422. The mean is 3,000, and the standard deviation is 500. And it says that D then should be $3,325.07. Yours has a tail. That allows you then to do this as a, you can do them and then as less than or equal to or greater than or equal to. So if you are picking less than, your tail should be left. If you're doing greater than, your tail should be right. Is that what the two options are?
Yeah.
Okay, center would be between two values then. So it'd allow you even to do an inverse norm between like 2,300 and 3,300, which is kind of a hassle without that option. But it would probably ask you then if you pick center to give 2 inputs or something. Or give you 2 inputs or something like that. Is that okay? So when I type this in and press enter, we got, so D is going to be $3,325.07. And I guess maybe did they tell us how to round to? I guess it didn't. It said dollars, though. I guess I probably don't need to include the pennies, but whatever. You guys are fine with pennies. So far, so good? Helpful? Coming back at all? Definitely necessary. Okay. Let's continue. It says the mass W of bags of rice follows a normal distribution. Again, it's a word I'm looking for. With a mean of 1,000 and a standard deviation of 4. So that would say that W is normally distributed as 1,000, comma 4. So that sentence in symbols could be written that way also. It says, find the probability that a bag of rice chosen at random has a mass between 990 and 1,004. So again, if we just kind of like sketch in a picture. We're looking for like that area, right? Does that feel okay with me drawing the picture of what we're looking for? Not going to do that every time, but I think especially early on as we're kind of reviewing, it kind of helps intuitively to draw a picture of what you're looking for. So on to my calculator. I'll go to the distributions menu. I'll pick normal CDF. My lower is 990 and my upper is 1004. My mean is 1000, standard deviation 4. Oh my gosh, what did I do? I did inverse norm. Did I do that? No. What happened there? Normal CDF. There it goes. Okay. So I got 0.835. So far, so good. It says 95% of the bags have a mass less than K grams. Find the value of K. So this is one of these kinds of problems. What do we need to do here? Inverse norm. And notice that this is the same whether it's less than or equal to. Why? Because it's a normal distribution. So the normal distribution allows me to be really willy-nilly with whether it's a less than or equal to or great or less than. Textbook. Okay. So we get K is about 1,006 grams. Everyone's okay there? Says for a bag of rice chosen at random, the probability that 1,000 minus A is less than W is less than 1,000 plus A equals 0.9. Find the value of A. So to help us kind of intuit what we're going to do algebraically, I'm going to draw myself a little picture to help. Everybody agree that this is essentially the picture that's being described there? Okay. So what I can do is I need to rewrite this so that it's not a compound inequality. So what if I say that's the probability that W is less than 1,000 plus A? The problem is that includes all of the yellow part, right? That's too much. So I can also just subtract off that part. Nope, that's not going to work. Although it's true. We need to do here. What's the trick? I see it now. Okay. So I know that this section has to be 0.45 and that section has to be 0.45, correct? Does everybody agree with that? Why can I say that? And I know that a normal distribution is symmetric, right? So if they're symmetric, then I can split it in half right through the halfway point. Everybody agree? Okay. So I have that. And then how much is that? .5, right? Because it's literally half of the curve. If everybody's okay there. So I can say the probability that W is less than 1,000 plus A is equal to 0.45 plus 0.5 or just 0.95. Are we all okay there?
What does W stand for?
W is the random variable representing the weight of the sack of rice or whatever the thing was. Is that okay? Okay. So now, what was the point of me doing all this? I had a compound inequality, and I've knocked it down to a single directioned inequality. This now I can do my inverse norm on. So 0.95, mean and standard deviation are such. So it's the same problem as before. That's pretty dumb. So I have that 1,000 plus A is going to equal 1,006 point, 58. So what is A going to be then? Just 6.58. Yep. So far, so good. Okay. Looking at 3, it says a fair coin is flipped 8 times. Calculate the probability of obtaining exactly 4 heads. So the first thing I'm going to say is that I'm going to use the random variable h to represent the number of heads when a coin is flipped 8 times. Now, I recognize that that distribution is going to be binomial. What are the criteria that I need to have so that I know that my random variable is binomially distributed? Great, that's one of them, yes. What else? Looking for the criteria here in the textbook. I can't remember them off the top of my head. I think it has a fixed number of trials, though. Yeah, that sounds right. And the probability has to be fixed. That kind of goes along with saying it's independent, though. Or it's a known. I guess we have to know it. But that sounds good. Everybody okay? Yes. Yes. Okay. So what is the probability of success here? Mm-hmm. And the number of trials is 8, right? I think that says 8. You're a huge disappointment, Geraldine. I'm just joking. I'm just like a regular disappointment. There's no reason this can't be fun, guys. Okay. I wrote this in the wrong order. Sorry. The number of trials is first and the probability of success is supposed to be second. Okay. So if I want the probability that H is exactly 4, I'm going to be using one of my binomial distributions. So I'm going to go to my calculator. So second, vars. Now the binomial distributions are down at the bottom. Do I want a PDF or a CDF here? Are we talking about one value or multiple values? One value, right? H is equal to exactly 4. Not less than 4 or greater than 4, but exactly 4. Exactly is going to be a PDF. Exactly one value is a PDF. So I'm going to pick binomial PDF. The number of trials is 8. the probability of success was, and the number of heads we're looking for is 4. So I type that all in and I press enter, and there's my answer. Hold on a second. Yes, Geraldine, what's up? Well, PDF stands for probability density function. But the thing you're thinking about when you see the difference between like a PDF and CDF, the P is for like the random variable equals one value as opposed to multiple values. So if it's an equal sign here, that's a PDF problem. If it's an inequality, it's a CDF problem. And I think that's actually, this number is capable of written as a fraction. If I math frac that, yeah, 35 out of 128 if you wanted a fraction there. Also acceptable. I think the back of the textbook gives it as a fraction. That's why I'm making mention of it. But decimal is fine, always fine, rounded to 3 sig figs, unless it says specifically to write it as a fraction or whatever. All right, 3B says exactly 3 heads. Quick, somebody do it. What'd you say? So second, vars, binomial PDF, 8, 5. This is now a 3.219. I think I just had some communication problem there, Joey. I think you said the right numbers. I wrote down the wrong things.
Oh.
Everybody okay with how we did that? No big deal there. Again, if you wanted that as a fraction, that's fine. Here we want 3, 4, or 5 heads. So there's 2 ways of thinking about this. When I see or inside of a probability, that means adding. So I could do it as 3 PDFs, which isn't bad because I've already calculated this one and this one in the previous 2 problems, right? So you could do this as a PDF problem. You just have to do a couple of them and add them together. Whatever, no big deal. So let's do it that way first. But we could also do it as a CDF, and I'll show you that in a second also. So we're going to have this answer plus this answer plus that answer. We get 0.711. Or we could do this as that, right? Everybody agree? That now looks like a CDF problem. The problem is that our binomial CDF won't let us do a compound inequality. You see how it's set up here? When I look at the binomial CDF, it doesn't have an upper and lower slot like it does for the normal. So to do this as a CDF, I'm going to have to take 5, and then we'll subtract off less than or equal to 2. And that should give us the same value, which it did. Does it matter which way you do this? Not a bit. Either is fine, thinking about it as a CDF problem or a PDF problem. This one feels like the PDF is much simpler because you've already gone and calculated 2 of the 3 that you needed for the PDF. Woo! That's nice.
I'm sorry, what did you call it? 5.
So I did 2. I subtracted 2 of these things. Yeah. So I have the first one, which is less than or equal to 5, minus less than or equal to 2, which is the same as strictly less than 3. You should have to be careful with the discrete ones because less than 3 is not the same thing as less than or equal to 3 here. Doesn't work that way for binomials, so you gotta be careful. Okay. Feeling okay so far? Coming back? Hopefully this feels like you're knocking some rust off here. Should we continue doing some more?
Sure.
I got all the time in the world here.
Is this basically already running this?
Yeah, it's going to be like almost all calculator, using the commands correctly.
More stuff you have to learn, or is this just...
I mean, there's a little bit of like formula stuff, but the formula stuff is super duper easy, like doing expectations and standard deviations, finding those things. But like, we'll go through and do some more stuff here.
Wait, we gotta, that's the next one.
So the quiz, yeah.
It just sounded like what we're doing today.
I have to double check and look. I'm just pulling questions from the chapter 12 review. You know, like some of this stuff might be after the quiz, where the quiz ends. I can't remember if the quiz covers normals or not. But we can take a look. All right, let's see. This seems like essentially the same problem we've done. This feels the same. Let's do that. I'm going to skip some of these for now because these feel very much like the ones we've just been doing. I'm going to jump here and look at some problems that are a little bit different than the ones that we've been doing. Is that okay? All right. A factory makes calculators. Over a long period, 2% of them are found to be faulty. a random sample of 100 calculators is tested. Write down the expected number of faulty calculators in the sample. So the first thing that I'm going to want to do is decide what kind of distribution these calculators are. So we have this population of calculators, and we're interested in whether they're faulty or not. Correct? When I read a question like that, how many outcomes are there? 2. That screams binomial. Okay? When there's 2 true outcomes, that to me says that this is a binomial problem. We have 100 things in our population.
The outcome being faulty calculator or not.
Correct. Yes, the calculator is defective or not. So those are the 2 true outcomes. So our probability of success, we're going to define as being faulty, since that's what the question is asking about. So we'll say that the P there is 0.02. Everybody feels okay there? So we'll say C is our random variable, and that's distributed as a binomial. So the expectation of C in a binomial setting is N times P. So we'd expect 2 calculators to be defective. Does everybody feel okay with that idea? (10b) says find the probability that 3 calculators are defective. Notice it doesn't say at least 3 or less than 3. It says just the probability that 3 calculators are defective. So should I be using, what type of binomial should I be using? CDF or PDF? PDF, good. Why? It's an equal sign, exactly right. So we have 100 trials. Our probability of success is 0.02, and we're interested that it's equal to 3. If I do that, I got 0.182. Find the probability that more than 1 calculator is faulty. So this is going to be a CDF, correct? Now, does our calculator allow us to do a tailed CDF for binomials? It does not. So this is going to be a big hassle, right? So what I'm going to do instead is I'm going to do this as a complement. So that's going to be the same thing as 1 minus the probability that C is strictly less than 1. Is everybody okay there? Now, in a binomial setting, strictly less than 1 is the same as C less than or equal to 0. Because if it's binomial, you can only have like it happens or it doesn't. So there's no chance of 0.5 happening. It's either less than 1 calculator is just 0 or less. right? And in all reality here, since it's 0, can't have negative defective calculators. It's just equal to 0 there. So that's what I'm going to do on my calculator, is I'm actually going to do a PDF here. So 1 minus binomial PDF x equals 0. So I have 0.867. Oh my goodness, guys. I'm so sorry. I misread this problem. It said more than one calculator. I have at least one calculator. So that should be greater than 1. So this should be less than or equal to 1. So this should be less than or equal to 1. So I should use a CDF here. I'm sorry. Go ahead. What did you say? Well, I put 0 in that case, but I'm going to just redo it here because now I'm doing a CDF. Oops, not a Poisson, though. I misread the problem. CDF 8.02. Now my x here is going to be 1. That doesn't make a lick of sense to me. Oh my God, yes. Why did I put 8? Because I'm still doing that problem we did from before. Ay caramba. There we go. That's a much more sensible answer. 0.54. My apologies. Right. Did you do 1 minus? So I have 1 minus the binomial, right? Did you remember to write that part in? Because if you didn't, that would make sense why you're getting 0.4 something or another. Oh, yeah, sorry.
So basically just put 1 minus and then work the probability.
Yes. Or else you could do like 99 PDFs and do the probability that C is equal to 2 plus the probability that C is equal to 3, you know, plus 4, plus 5, plus 6, all the way up to 100. No, thank you. I like this way a lot better. So taking advantage of that complement rule. Okay, let's do number 11. I suppose that seems like a good one. So it says ball bearings are used in engines in large quantities. A car manufacturer buys these bearings from a factory. They agree on the following terms. The car company chooses a sample of 50 ball bearings from the shipment. If they find more than 2 defective bearings, the shipment is rejected. It is a fact that the factory produces 4% defective bearings. So pretty clear that this is another binomial distribution. Everybody agree it's the same, either it's defective or not situation. What is the probability that the sample is clear of defects? So we want the probability that B is equal to 0. Right? That we've chosen 50 of these ball bearings and just none of them are defective. So this is going to be a binomial PDF. So here we have 50 trials. 4% of them are defective. And we want 0 defects. So that happens about 13% of the time. Is everybody okay there? What is the probability that the sample is, or the shipment is accepted? That means the probability is less, or the probability that the bearings have less than or equal to 2 defects. Everybody agree there? So that's going to be a CDF. So 0.677. And then 3 asks, what is the expected number of defective bearings? So we have the population times the probability of success. Well, that's going to just be 2. Grace.
What if 11B was like greater than?
Was greater than what?
2.
Then I would do the same thing I did up here.
The 1 minus.
Yep. 1 minus, and that allows me to flip it to a less than, which then I can do in my calculator.
CDF just like knows that you're doing less than.
It is built into your calculator that it's less than. Well, it's actually built in less than or equal to. Yes. Does that sound okay? Let's pause here and talk about quiz format. Sound okay here? Okay. So if I give you a probability distribution, you should be able to solve for a variable or variables. So if we look at, like example 2 or example 3 from the in-class examples in 12.1, you should be able to do something like that. We didn't do one of those today. Probably bad on my part. So you should be able to calculate the expected value from a probability distribution. So like, again, in 12.1, we asked you to do that exactly here. So all you do is you take the value times the probability, value times probability, value times probability, value times probability, and add them all up. So you should be able to take a situation recognized as binomial and write it as symbolically, like random variable x is distributed as the binomial n comma p. So you should be able to kind of write something in that form where you filled in the letter for x and the values for n and p. Just from reading the question.
Would NP
The number of trials,
is the
probability of success. So you should be able to calculate mean or expected value and standard deviation for binomial distributions. And you should be able to calculate probabilities for binomial distributions using PDF or CDF on your calculator appropriately. So again, I would, if I were you, I would run through the in-class examples for 12.1 and 12.2. If you do that and you feel reasonably okay, you should be all set to go. The formulas here that I listed for expected value and standard deviation for binomial distributions would be given to you on the quiz. You don't have to memorize those. Those formulas will be on the quiz. I just wrote them down here, so as a reminder. Everybody feel okay there? It's relatively short. I count 8 questions total for the quiz. Yeah.
Wouldn't that calculate the standard deviation for the binomial distribution? Can you do one of those?
So if I wanted to do the binomial distribution for like this guy, it's going to be n times p times 1 minus p. That's it. So just 100 times 0.02 times 0.98. And I'm done. That's it.
Wait, n times p.
Times 1 minus p. Look, I wrote it down right here. But it'll also be given to you on the quiz. Like, you don't have to memorize it. But that's all you have to do. Yeah, Joey. That we did a bunch of examples doing exactly those sorts of problems. Yes. Exactly right. Again, if your best studying for the quiz would be to look through the in-class examples for 12.1 and 12.2. If you feel decent there, should be smooth sailing.
Did you see the ones last year?
Okay?
It's like the tank top with the sleeve.
I hate
Two of them. Two?